previously decimal expansions are given, we converted them to a rational number. Now rational number is given, how to write the corresponding decimal expansion. Let us check whether the decimal expansion terminates or non-terminates. 3 by 8. 3 by 2 cube. 8 is 3 cube. 13 by 125. 125, how to write 125? 13 by 125. 13 by 5 cube. 7 by 80. 80 on prime factorization. 18 in the prime factorization, you can write 2 raised to 4 into 5. 18 in the prime factorization. Prime factorization, that will come as 2 raised to 4 into 5. 80, the prime factorization gives 2 raised to 4 into 5. Okay, now let's see the decimal expansion. The decimal expansion divide here. 3 divided by 8. 3 by 8. In smaller classes we studied like that. 3 divided by 8. 3, 8, 4, 30. 30, how many times 8 can move? Going 30. 30, let the brush on 8. 3 times. Then 24. The remainder 6. We can put a 0. Then 7. 7, 8, 56. Then 40. 5 times 40. Terminates. Decimal expansion terminates. 0.375. Next, 13 by 125. 13 by 5 cube is 125. 13 by 125. First of all, in 125 there 0. In 130, how many times? 1 time. 125. Remainder is, what is the remainder? Remainder is 5. Remainder is 5. In 5, then we can have 50. Will it go? No. I have to put 0 here. 100 for the 4 times. 125 into 4, it is 500. So what we get? 0.104. The next one. Similarly, we have 7 by 80. 7 divided by 80. 0.70 we don't go. Then one more 0. 700. In 700, how many times? 8 times. Then 640. Then on 640, 60. One more 0, put one more 0. How many times? 7 times. Then it is 560. Then 40. 400 it is 5 times. So we get 0.0875. Actually these all we have done. Okay. Now what we are going to conclude, in the previous theorem, theorem 1.5, we studied that if a rational number whose decimal expansion terminates, then its denominator will be in the form 2 raised to n, 5 raised to m. In this, we are going to say that if the denominator of a rational number is in the form 2 raised to n, 5 raised to m, then its decimal expansion terminates. Clear? ഏതെങ്കിലും ഒരു റാഷണൽ നമ്പറിൻ്റെ ഡിനോമിനേറ്റർ 2 raised to n, 5 raised to m എന്നുള്ള രീതിയിലാണെങ്കിൽ അതിൻ്റെ ഡെസിമൽ എക്സ്പാൻഷൻ എന്ത് ചെയ്യും? ടെർമിനേറ്റ് ചെയ്യും. ഇനി ഇതിങ്ങനല്ല എന്നുണ്ടെങ്കിൽ ഡെസിമൽ എക്സ്പാൻഷൻ ടെർമിനേറ്റ് ചെയ്യത്തില്ല. That means it is non-terminating. Decimal expansion will be non-terminating, recurring. Why we call it as recurring? It's repeating. If it is a rational number, definitely its decimal expansion, either it is terminating or non-terminating, recurring. Recurring means repeating. Okay, now we have theorem 1.6. This is the last section of our chapter. Theorem 1.6. What it says? Theorem 1.6 says that let x is equal to p by q is a rational number. Then the prime factorization of the q will be in the form 2 raised to n, 5 raised to m. Then this decimal expansion of this rational number terminates. Clear? When you rational number p by q, q is the denominator. When we find the prime factorization of the denominator, if it is in the form 2 raised to n, 5 raised to m, that rational number, whenever we take the decimal expansion, that decimal expansion terminates. Terminate means ending. Clear? Is it clear? Okay. The That is the last section of this chapter, theorem 1.5. What is theorem 1.5? Theorem 1.5 says x be a rational number whose decimal expansion terminate. Then x can be expressed in the form p by q. P and q are co-prime. The prime factorization of q of the form 2 raised to n, 5 raised to m. Okay, the converse of that is theorem 1.6. What do you mean by converse? The opposite. Then x is equal to p by q. It's a rational number such that the prime factorization of q is of the form 2 raised to n, 5 raised to m. Then x has a decimal expansion which terminates. Now we move to the last section which says that theorem 1.7. Theorem 1.7. Theorem 1.7 is like this. Let x is equal to p by q is a rational number such that the prime factorization of q is not of the form 2 raised to n, 5 raised to m. Is not in the form 2 raised to n, 5 raised to m. Then x has a decimal expansion which is non-terminating, repeating. അതായത് ഏതെങ്കിലും റാഷണൽ നമ്പറിൻ്റെ ഡിനോമിനേറ്റർ 2 raised to n, 5 raised to m എന്നുള്ള രീതിയിലല്ലാതെ വന്നാൽ അതിൻ്റെ സിംപ്ലിഫൈ ചെയ്യുമ്പോഴാണ് ഇങ്ങനെ സിംപ്ലിഫൈ ചെയ്തിട്ട് ഇങ്ങനെ വന്നാൽ അതിൻ്റെ ഡെസിമൽ എക്സ്പാൻഷൻ എന്താവത്തില്ല, ടെർമിനേറ്റ് ചെയ്യത്തില്ല. ഇറ്റ്സ് ഡെസിമൽ എക്സ്പാൻഷൻ വിൽ നോട്ട് ടെർമിനേറ്റ്. അത് എന്ത് ചെയ്യത്തില്ല. നമ്മൾ ലാസ്റ്റ് ഇയർ പഠിച്ചതാണ്. ലാസ്റ്റ് ഇയർ വി ഹാവ് സ്റ്റഡീഡ് 1/7. ഡു യു റിമെമ്പർ 1/7? 0.142857, again 14285, etc., etc., etc. Denominator is 5. It will not end. If the denominator 2 by 3, what we get? 0.666666. It's non-terminating. Denominator 3 ആണ്. If it is 8, it will terminate. It is in the form 2q. If it is 125, that is a 5q, or 25 or 50, it's equal to 2 into 5. Such cases only terminate. These cases will not terminate. Okay, now we can move to the exercise 1.4. That is the last section of this chapter. Study this chapter, do all the exercise problem and clear your doubt. You can call me and ask your doubts. Let me to discuss that exercise 1.4. Page number 17. May I continue? Without actually performing the long division, state whether the following rational numbers will have a terminating decimal expansion or non-terminating decimal expansion. Without actually performing the long division, we have to state whether the following rational numbers will have a terminating decimal expansion or non-terminating decimal expansion. Exercise 1.4. Please take the textbook. Exercise 1.4. Exercise 1.4. First question. 13 by 1325. നമ്മൾ ന്യൂമറേറ്ററും ഡിനോമിനേറ്ററും സിംപ്ലസ്റ്റ് ഫോമിലായിരിക്കണം. 13 is a prime number. We cannot further factorize it. This number actually it is 5 raised to 5. It's 5 raised to 5. You have to do the prime factorization. This is 5 raised to 5. This is in the form 2 raised to n, 5 raised to m, where that is 2 raised to 0 into 5 raised to 5. So its decimal expansion terminates. Okay, another 17 by 8. That is 17 by 2 cube. So it is terminates. Another example, 64 by 455. 64 divided by 455. We can check whether the decimal expansion terminate or non-terminate. 64, we can write it as 64. How to write it? Do you remember 64, 2 raised to 6? 32, again 2, 16, divided by 2, 8, 4, 2, 2. That is 2 raised to 6. Then 455. 455, how to write it? 455. We can divide by 5. 45, it is 91. 91, we can divide we can divide by 7. On dividing by 7, it is 13. Okay, these are prime number. 5 into 7 into 13. 7 and 13 in denominator vannu. So it is non-terminating. Non-terminating. Okay, like that, would you please complete rest all questions? Would you please complete rest all question by this method? Okay, then another question. 29 by 343. This 29 is a prime number. 343 is 7 cube. So it is non-terminating. Like that, please. 6 by 15. 6 by 15. 6 it is 2 into 3. 15 is 5 into 3. Get cancelled. That is 2 by 5 in the simplest form. See, so it is terminating. I hope you understood the first question. Move to the second question of exercise 1.4. I am moving to the second question of exercise 1.4. Write down the decimal expansion of whose rational numbers in question number above which has terminating decimal expansion. നമ്മൾ terminate ചെയ്ത് എഴുതുന്നത് എങ്ങനെയാണെന്ന് ഞാൻ പറഞ്ഞു. You have to write that in decimal expansion. അത് decimal ആയിട്ട് convert ചെയ്യണം. That you can divide, for example, you have 17 by 8. That is 17 by 2 cube. അത് നമുക്ക് ഇവിടെ denominator ഒരു 5 കൂടെ multiply ചെയ്താൽ മതി. Denominator and numerator multiply by 5 cube. Otherwise, you carry out the division 17 by 8. Both will get the same answer. Either you can do this method or this method. 17 divided by 8. All the questions can be done like that. Okay? All the questions can be done like that. This one, in all the questions, we can do by this method. One question, last question, 77 by 210. 77 is 7 into 11. 210 is 7 into 2 into 5 into 3. Isn't it? 7 into 3, 21 into 10, 210. See, 7 get cancelled. Then 11 into 2 into 5 into 3. Will not get cancelled because it's non-terminating. 3 ഇവിടെ ഉണ്ട്. 2 is non-terminating ആണ്. Okay, try that question. If you have doubt, you can ask me. Then the last question of exercise 1.4. The last question. The following real numbers have decimal expansion as given below. In each case, decide whether they are rational or not. If they are rational, write them in P by Q form. What can you say about that you studied last year? First one, 43.123456789. The terminating ആണ്. Since it is terminating, it is rational number. Decimal expansion terminate ചെയ്യുന്നുണ്ടെങ്കിൽ അത് rational number ആണ് കേട്ടോ. That you can write in the P by Q form. The next one is 0.120120012000. Last year we studied like this. Is it a rational or irrational? It is irrational, non-terminating, non-recurring. The last one is 43.123456789 bar. It is a rational number, but it is not terminating. Non-terminating, recurring, so it is rational. 1 and 3 are rational, 2 is irrational. First one, terminating, decimal expansion, rational number. Second one, non-terminating, non-recurring decimal expansion, it is irrational. Third one, non-terminating but repeating, so it is rational. I shall send the answers of these third questions in the note. Third one I will send. Okay, thank you very much. Please study the lesson, ask your doubt, practice and more practice. This is the shortcut to study mathematics.